The reason this video came about is because I've been using Poundworld's rechargeable nickel metal hydride cells, which used to be rated 1000 milliamp hour. And if you look at the original casing, it says 1000 milliamp hour, and they actually test a bit higher than that. And I thought that's pretty good. And I noticed after I bought them that they looked a bit different. For a start, the top was sort of matte instead of shiny. And the rating, it's unreadable. It looks like 900 milliamp hour because it's got the slanty lines going through it. And then it could be 800 milliamp hour. And it turns out it's just kind of maybe disguising the fact it is 800 milliamp hour capacity. And that means they're now equal to, well, so I thought, Poundland's 800 milliamp hour cells. They've always sold them as being 800 milliamp hour. So I decided to do some tests and see what the capacity was, and for that I used my special battery tester that I built some time ago based on a clock. It's a quartz amp hour ohmmeter. And basically speaking, this is a quartz clock that's been adapted. The hour hand has had the pointer extended for accuracy with a bit of wire, and the second hand has been cropped down. The point of the second hand is purely to show it is still actually discharging. And my original idea, after having made this and changed the display and set it up, the idea was that it was going to discharge at roughly 500 milliamps, so that every 5 minutes would have been, well, every minute effectively that the hour hand passed would be 100 milliamp hour. It was just a nice way to divide that. And it came into a wide range of cell capacities. You know, it kind of made it sort of accurate and kind of future-proof. And originally my idea with this was that I'd simply take a couple of wires out the battery, out the quartz movement, and I'd put a resistor or electronic load across it to discharge the cell in the quartz movement at about 500 milliamps. And I thought that, you know, the quartz movement will work down to quite a low voltage, but it didn't work. You see, the quartz movement stopped before 1.2 volts, and that's a bit of a crime because if you put in an alkaline cell is rated, the capacity is rated from the point of course from 1.5 volts down to 0.75 volts. And that means it's going to use a fraction, a really small fraction of the energy of the alkaline cell. But in my case, it didn't work and I had to do a little hack. So I introduced the test socket and I wound a good number of turns onto a reed switch. A reed switch is a magnetic switch where you've got two metal contacts inside a glass envelope, and when you hold a magnet nearby, they click together. It's a very simple device. It's completely sealed against contaminants, widely used in the telecommunications industry, and it provides a really solid connection. Reed switches are great. And so I wound the reed switch, measured the resistance, and just used a buffer resistor in series just to kind of nudge that up so the average discharge current was going to be about 500 milliamps. Technically speaking, I could have made a simple two transistor circuit that made it exactly 500 milliamps. I may do that in the future, but this is pretty accurate. So you put the cell in here, you wind the clock hands back to the start like this, back to 0, which is also 6 amp hour, and you put the battery in and just leave it sitting, and when the clock hand stops, the second hand stops, that's you got your how much capacity it was. I'll just let you admire my recording illumination setup at the moment. It's a temporary rig on a bit of wood fastened to the wall with a shelving bracket. It's got two fluorescent tubes and the phone just beeping over a shelf there and recording what's going on. So that's out the way. I did the tests and the Poundworld cells were an absolute apocalypse because their cells used to charge, they used to show a charge of about 1200 milliamp hours. They used to be really, really good. Not anymore. These cells, which are marked 800 milliamp hour, only took a charge of about 600 milliamp hour, whereas the Poundland cells that are rated 800 milliamp hour, well, let's show you the results. Here's the results. Let's get the batteries out of the way. If you hear me interchangeably using the words batteries and cells, I should explain that in this sort of electronic terminology, this is a cell. It's just a single cell. But when you put several of them together, if I put these two cells into a battery holder, then it becomes a battery of cells. So that's where the terms battery and cell come from. And I'm afraid to say that the results for Poundworld are bad because the Poundworld 800 milliamp hour cells actually they only took 600 milliamp hour, but impressively, out the pack, they were still holding 450 milliamp hour. I tested them straight from the pack without charging them initially. The Poundland cells excelled themselves. The actual capacity fully charged is 1,100 milliamp hour, but out the pack, they delivered the full 800 milliamp hour on the pack. So that kind of shows, given they've got quite a modest sort of date, it doesn't show the date of manufacture, so I would just guess that, they've been probably sitting on a shelf for a while. But it shows that they're not really losing their charge. It's almost like the Eneloop cells, that they have a low self-discharge. Traditionally, one of the biggest problems with nickel metal hydride cells was the fact that, if you charged them up and left them, the voltage went down quite quickly. And that is especially the case with the really high capacity, 2,500 or 3,000 milliamp hour cells. That's probably why the Eneloop cells they don't really do them in the super high capacities close to the sort of maximum capacity you can get, because by using a thicker separator, presumably is the main thing, or a different separator chemistry, they get that very low self-discharge. And these seem to have an Eneloop-like low self-discharge. You can actually charge them, put them in a shelf for a very long time, and they'll still have a very large portion of the charge pretty much a year later. So that makes them very, very useful. And these cells, it might not seem much capacity, the sort of 1,000 milliamp hour type capacity, but these are fine for most applications. If you consider that an alkaline cell is rated for, it's rated for that 1.5 volt going down to the final cell voltage of 0.75 volts, half the starting voltage, then most electronic stuff like that quartz clock will stop long before that. So when you've got something that just sits, nickel metal hydride cell starts at 1.5 volts, but then it goes down to 1.2 volts and then just holds that almost in a flat line right to the end of charge, and then it suddenly tails off. And that means that even with a low capacity or a seemingly low capacity cell like this, you'll quite often get much better results than you would with a generic alkaline cell. So that makes them very good. And of course you can recharge them. Oh, here's another thing, and this is where it just really falls down. Most of these say you can recharge them 1,000 times. So what does it say? High capacity, service life up to 1,000 charge, long service life up to 1,000 charge discharge cycles. I'm not sure if this is just a mistake, but this one basically says long service life up to 100 charge discharge cycles. I hope that's not the case. I doubt it. But other applications, even though the Poundworld have just slopped, they've gone from these shiny top cells to these lower capacity matte top cells. I'll just show you them so you get a comparison. Shiny, matte, shiny good, matte crap. And also, can I mention the first clue was when I took them out of the packet and the weight was so different, it was so light. Hold on, I do have a set of scales. Let's weigh them. You know what? Let's be complete here and weigh these. So let's get a set of scales up. I'll just surreptitiously wipe the dust off my scales before I put them into view. There we go. Oh, is that going to be even visible? I'll just have to read it off for you. And it's kind of reflecting the light and swamping it. Oh well. So these two cells are showing a weight of 30 grams. So 15 grams per cell. Let's see, I'll just put one of those on. 21 grams for one cell. So let's, hold on, let's do it individual cells. 15 grams, 21 grams for the original higher capacity cell, and the much lighter one for the lower capacity. And what's the Fusio Max? 20 grams again. So yeah, I would say that when you get to the 20 gram mark with these sort of generic cells, that is roughly about the 1 amp hour you're going to get from that. It's not an exact science, just relating weight to capacity like that, but in this case it seems to work. So yeah, now Poundland are back as my favourite battery now, the Fusio Max. They're better than Poundworld because Poundworld appear to have dropped the ball and cheaped out. Oh, one last thing. If you've got solar garden lights, all these cells will work fine in them. These are all really well suited because they do have a tolerance, good tolerance to trickle charging, long trickle charging at low current. And they're just ideal for those low charge cyclic applications.